Our next lesson is about solving quadratic equations using square roots. So before we do any solving, I have listed all of the square roots of the perfect squares up to 15 times 15. You don't have to copy all of these down. I think you probably know most of them. However, I recommend that you copy down any that you might not know and make sure that you learn them. The ones I think that most people either don't know or have forgotten are the square root of 169, 196, and 225. So just make sure that you know them. You need to have those memorized for this chapter. And then everything else is also listed, but I think that you probably know most of the ones up to 10. So then we're going to actually go through some examples. And for all of these examples, I am going to ask you to solve the equation. And you'll notice in this chapter, everything that we're going to solve has an x squared in it. Those are called quadratic equations. So my first example is x squared minus 144. And I'm actually going to ask you to solve it using square roots because there's other ways that you can do this. For example, you might be able to solve this by factoring. But I'm going to show you how you can do it by solving using square roots. So to do that, you're going to start, your step one is going to be to get the squared variable by itself. So when we were factoring, we always solved for 0, but in this case, when you're solving using square roots, you're going to get the squared variable by itself. And just kind of a side note that's important is that you're going to be using this method. The times that you're going to use it the most is when you have no middle term with an x. So no just plain old x term. So you notice we have a constant, we have an x squared term, but we have actually no x term. So that's usually when we use square roots. So continuing on, we're going to start by getting the squared variable by itself. In this one, it's actually very easy. All you need to do is move over this 144 by adding it to both sides. Then we end up getting x squared equals 144. So then we only have one more step on this, and that is going to be to take the square root of both sides. And it's also very important that you include both positive and negative square roots. And I'll explain what I mean by that in just a second. So we are going to take our equation that we have, x squared equals 144. We're going to take the square root of the left-hand side. When you take the square root of x squared, you get plain old x. That's our goal, is to solve for x. But since we did that on one side of the equal sign, we have to do it on the other. And we get the square root of 144. The other thing that is very important is that we actually are going to include both possibilities. We can either have it being a positive answer or a negative answer. So my two answers are going to be positive 12 or negative 12. I often write it as plus or minus 12, but you can also write it as x equals 12 and x equals negative 12. So either of those two answers are acceptable. So the reason that it works out, I'm going to show you how to check your answer. This is kind of a side thing. So we started off with x squared minus 144 equals 0. So the reason that it works out that you have two answers is because, yeah, if you put in 12, positive 12, you do get 144 minus 144. That's good, which is what we want. But it also works out if you have negative 12 squared. So negative 12 squared is negative 12 times negative 12. Since you multiply a negative times a negative, you get it to become a positive 144, which also gives you 0. So that we got what we wanted when we checked it. So make sure that you include both answers. That is very important. The next problem is a little strange, but once you know what to do, you'll find it's actually very easy. So what we're going to do, we want to solve for x. We do that by adding 21 to both sides first. Then you end up getting x squared equals 21. So a lot of people would stop here and get a little bit worried because 21 is not a perfect square. That is true. So since we don't know exactly what it is without a calculator, what you're going to do, take the square root of both sides, add in your plus and minus. Your answer actually will just be x equals positive and negative square root of 21. And that's all you do for that one. So our next problem involves a little bit of extra work. We need to start, remember, by solving for our squared variables. So we're solving for the m squared. I have to move over my 3 first. So this is 3 times m squared. I am now going to get m squared equals 25. Suddenly this problem got a lot nicer. I take the square root of both sides, make sure to put in my plus and minus. I get m equals positive 5 or negative 5. So you can either write it like that, or you can write it as m equals 5 and m equals negative 5. Both of those are acceptable answers. So here I have 2 more problems. You are still solving for whatever your variable is. I would like you to pause and try them on your own. So for 4, we're going to start by dividing both sides by 4. We get x squared equals positive 9. Then we take the square root of both sides, and we're going to add in a plus and minus. We get x equals positive or negative 3. For number 5, you're going to start by moving over that 10. The next thing you have to do is move over the 3 by dividing both sides by it. Then you're left with m squared equals 9. So from there, you are going to take the square root of both sides, add in your plus and minus. You get m equals positive or negative 3. So our next 2 problems are our 2 special cases. For the first one, you are going to start by moving over that negative 20. You end up getting y squared equals 0. From there, you will take the square root of both sides. You end up getting y equals, now most of the previous problems you would actually go ahead and do plus or minus. However, plus or minus 0 doesn't make any sense, so we're actually just going to write it as y equals 0, because 0 is neither positive nor negative, so you just are going to have one answer. So this is our special case where we have only one answer. And then for number 7, this is our other special case. You start by subtracting 8 from both sides. You get x squared equals negative 6. So now you can try to take the square root of both sides, but you'll find that if you remember back to previous classes that you might have had, you are not allowed to take the square root of a negative number. That is not allowed. You can even try to think of a possible answer for this and then plug it back in for x squared. You will not get a real number. There's no way to do this. It will not work. So this one we say there is no solution. And actually, just a side note, in Algebra 2, you will be able to do this type of problem. However, this negative 6 is going to be what we call an imaginary number. So you don't need to know that for this class, but in future classes you will actually work this problem out. So we have 2 more problems, and they are both a little bit more complicated. For this one, we're not actually going to be solving for an x squared because we have an entire binomial squared. So what we're going to do is we are going to try to get this entire thing by itself. So we're going to aim to get the entire binomial squared, the x minus 2 squared, by itself. That's our goal here. Once you have something squared by itself, then you are allowed to take the square root. And we're going to do that by dividing both sides by the 5. So this is one of our special types of problems. So I'm just going to caution you, please do not try to multiply out x minus 2 times x minus 2. Otherwise, you'll get something really, really big, and you don't want to have to deal with that. So we're going to divide both sides by 5. When you do that, you end up getting x minus 2 squared equals 9. So I think I just said it a minute ago, but it's important to notice that when you have anything squared by itself equals a number, you can actually take the square root of both sides. You are allowed to do that. So take the square root of both sides. So on our left-hand side, we're going to take the square root of that. Right-hand side, we're going to take the square root of that. And don't forget, the square root of 9 is still going to be plus or minus. So left-hand side, everything inside is not going to change. So you don't change anything inside. However, on the right-hand side, we now are going to have plus or minus 3. So our squared disappeared. We took the square root of 9. Now we have some nice stuff. And I'm going to go ahead and move over that 2, and then we're going to work out what we can do next. So we get x equals 2 plus or minus 3. I just put things in order, but it doesn't really matter how you write it out. So what that means is we're going to have two possibilities for x. We can have x equals 2 plus 3, which gives us x equals 5, or we can have x equals 2 minus 3, which gives us x equals negative 1. These are our two possible answers, and we are done with the problem. So for our last problem, I would like you to pause and try it on your own, please. So for this one, you're going to start by moving over the 3, get rid of the 3. By the way, just to note, you do not change anything with the x plus 8 squared. You already divided the 3 by the 3, so that's all you need to do for that side. You don't need to change anything with the x plus 8 squared. On the right-hand side, we do 27 divided by 3. That gives us 9. So now we are going to take the square root of both sides. Don't forget the plus and minus. That gives us x plus 8. It's no longer squared, equals plus or minus 3. So to get my x by itself, I need to move my 8 over. I will now get x equals negative 8 plus or minus 3, which I'm going to split up into 2, and I get x equals negative 8 plus 3, and x equals negative 8 minus 3, which is going to give me x equals negative 5 and x equals negative 11. By the way, on the previous one, I didn't actually check it, but if you want to go back and check your answer, you can. I highly recommend that when you're doing a test or quiz. I'll show you what you would do here. So we'll start with the x equals negative 5. You take your original equation and substitute in the negative 5 for x. And just make sure everything works out. You get 3 times positive 3 squared. So positive 3 squared is 9, so you get 3 times 9 equals 27. That is true, so we're good on that one. You do the same thing for x equals negative 11. You get 3 times negative 11 plus 8 all squared. That gives you 3 times negative 3 squared. So you do negative 3 times negative 3, that gives you 9 again. And once again, 3 times 9 is 27, so we're good on that one. So if you're in the CP class, this is going to be your last problem. If you're in the honors, we actually have 2 more after this. So the first thing I do for this problem is I'm going to divide everything by 7. That gives me x squared equals 100 over 7. From there, I am going to take the square root of both sides. On the left-hand side, I have just x. On the right-hand side, I have plus or minus 100, square root of 100 over 7. So one thing I am allowed to do is I can change that to square root of 100 over square root of 7. I can just do those two things separately. And from there, I don't know what the square root of 7 is, but I know that the square root of 100 is 10, so I would write this as plus or minus 10 over the square root of 7. That's all I need to do for that one. We'll find another thing to do later on in the year, but for now, this is all you need to do for that problem. So once again, if you're in the CP class, you can stop here or you can go ahead. If you're in the honors, we have 2 more problems. So for number 11, we have 4 over 3 times k minus 6 squared equals 20. If you think you know what to do, feel free to pause and try it on your own. If not, that's fine. I'll go ahead and go over it. So the first thing that we do for this type of problem is get rid of the 4 over 3. Get rid of your fraction. You do that by multiplying both sides by its reciprocal, which is 3 over 4. So on the left-hand side, we actually don't change anything with the k minus 6 squared because we've already multiplied the what's outside of it by 3 over 4. So the 3 and the 3 are going to cancel out. The 4 and the 4 are going to cancel out. We're just left with 1 times k minus 6 squared. And on the right-hand side, I would recommend you cross-cancel some things. So the 20 and the 4 can cancel to 5 and 1. So we're just going to be left with equals 15. From there, I am going to take the square root of both sides. So the left-hand side is just going to become k minus 6. The right-hand side, 15 is not a perfect square, so I'm going to keep it as plus or minus the square root of 15. All I need to do from there is move over that 6. That gives me k equals 6 plus or minus the square root of 15, and that's all I can really do with that problem. So my last problem is a little bit interesting because of the fraction. There are several ways to do this, but by far the easiest way is to get rid of that squared first. You get rid of something squared by doing the square root of both sides. So now on the left-hand side, I have t minus 5 over 3 equals plus or minus 7. So when you have a plus or minus in the middle of a problem, it's a little hard to work things out with it. The easiest thing to actually do is to split it up into 2 from there. So I'm going to now rewrite this as t minus 5 over 3 is equal to positive 7, and t minus 5 over 3 is equal to negative 7. So now I will multiply both sides by 3. I have to get rid of that 3, otherwise I can't get that t by itself. That gives me t minus 5 is 21. And last of all, I add 5 to both sides, I get t equals 26. And on the right-hand side, or on the rightmost problem, I'm going to write it as t minus 5 equals negative 21. I multiply both sides by 3 again. And when I add 5 to both sides, I get t equals negative 16. So that is my second answer.